one.
Okay, thank you, Daniel. Hello, everybody. Welcome to our first Cruise Data Science Learning Labs. This is the Learning Lab 0, where the goal of those labs that are going to be a talk is how to create some R Shiny apps to increase the business value of your company and your organization and your work. So I'm just going to start sharing my screen and we can get started. So let's talk about the presentation, and I should have gone to the first one. So again, this is an introduction to the R and Shine for this Lab 0. What you're going to be talking today is you're going to be talking about what is data science, so what you want to do as a data scientist and how is our workflow, then day by day. We're going to talk about what is the Data Cruise Data Science Initiative that you're starting at the University of Calgary with Cruise, the data science path or the learning labs. That is going to be the series of presentations that you're going to do bi-weekly, and it's going to be more a little of hands-on. We're going to go through the codes and how to do the applications. And I'm going to talk about introduction to R and Shiny, those packages that I'm going to be using for all those analysis and applications. And by the end, we're going to open for you you can type there any questions. And if you have any questions now, any problems, Daniel is the co-host and he's going to be helping and everything that's happening. So this lab today is being hosted by me. I'm Marcelo Guarido. I'm a data science at Cruise, and I'm a PhD in geophysics. And now I can say that I'm the head of the Cruise Data Science Initiative that you're having. And Daniel Tread, would you like to present yourself, Daniel?
Sure. Good morning, everybody. So yeah, we are with Marcelo and some other helpers. We are trying to get more and more into this world of machine learning. And Marcelo is, through this initiative, is going to be doing a lot of more advanced topics and research. And then myself, I'm putting together some grad course on this. So there will be a bunch of different directions will be taken in the next few months on machine learning, and this is the starting point.
Daniel. So we're going to start and talk about what data science and machine learning are. Those are some buzzwords that you're hearing a lot, and actually those are quite important. So first, let's talk about what's machine learning, the research. So we have a group that you can identify, that is the artificial intelligence. It's a big area where the researchers are trying to create programs that has the ability to learn and reason like humans, to think like a human. Inside it, so it involves like psychology besides programming, and a lot of things are together. And we have also the machine learning area that's inside the artificial intelligence. The machine learning is the one that you're working now, that involves algorithms that learn from the data without being explicitly programmed, like neural networks, random forests, all those algorithms that you're using to do predictions and forecasting information from our data sets. And we have inside the machine learning, the deep learning area, that's everything that's related to neural networks, everything that has 2 or more layers. And the machine learning can be divided by 3 main parts. The first one is the supervised learning, and then we have the unsupervised learning and the reinforcement learning. Supervised learning is when we have data sets where we have the answer. So we can train our data where we know the answer, so we can fit a model there that are going to predict the answers that we know, and then we can apply this model to data that we don't know the answer. And a lot of things that we do for that is forecasting, customer recommendation, image classification, fraud detection. So for unsupervised learning, We separated the supervised learning into classification and regression. Regression is when we have continuous data, like the weight of a person. It's continuous data, if you have a data set for that. And you have classification, when you have categorical data. It's like the gender of people. So it's just categories. We have the unsupervised learning. It's when we don't have the answer of the data. So basically what you are trying to do, you are trying to group data by their similarity. And we divided these in two main areas that it's clustering, where you create clusters based on the proximity of the data set that you have, and dimensionality reduction, when you have high dimensional data and you want to do 2D or 3D visualizations of that. And reinforcement learning, I like to say that's a combination between both supervised and unsupervised. It's when you have a kind of algorithm that's gonna learn by rewards or errors. So it's learning by the time as well. It's very common for video games and all those things. And for self-driving cars, that's very powerful in the University of Alberta, for example. The data science, so it's a professional that requires a lot of skills. So to be a data scientist, it's a combination of people that knows math and statistics, has some background in computer science, and needs to have the domain expertise of the area. So it's not that easy to be a data scientist, actually. And one of the things that most data science usually not lack, but is not their strongest part, is the domain expertise. So a lot of people has math and statistics and computer science, but to be in the domain of expertise, it's very hard because a lot of people come from different areas. And here, now we're gonna talk about the CRUISE Data Science Initiative, and that we are focusing in the domain expertise, actually. We wanna use our domain expertise, math, statistics, and computer science that you're learning through this series to create the data scientist you can be. So the CRUISE Data Science Initiative, we're gonna explain. The CRUISE is famous for this seismic project that we've done, like all the interpretation that can get from the seismic data. We have like examples are inversion, converted waves, blended data, well tying, and many other works. Also, we have expertise in data interpretation for oil and gas industries and any other. And that's our domain of knowledge. So we have the knowledge in geophysics that include in our area seismic, gravimetry, rock physics, and among others. We have expertise in petrophysics, like well logs, and also in the oil and gas and in geoscience overall. So we have understanding of reservoirs, production, and geology. And you can connect all those expertise. Those are different professionals. Each one has different expertise domains, but you can connect them all, and you can create a group that's a very powerful data science group. And also, as a data scientist, as the Data Science Initiative, we're going to provide courses like basic programming in Python, R, and MATLAB. Machine learning programming, it's a little more specific, but we're going to use in general cases with general data set that can find online, and some custom machine learning programming that we can get from the sponsor specific or anyone that want to have a course, give the data, we can do a more specific course. And also we want to do mentorship when you have questions and anything, you can work with this kind of thing. So for this series that you're talking about, now that we introduced what is the CRUISE Data Science Initiative, we're going to be talking about those data science paths or learning labs, the series that you're going to understand how to become a data scientist. So to a data science project, follow all those steps. First, you have to understand the business goals. We have to understand what are the questions that we need to answer, and understand the business, what you want to get from that. We have to have the key performance indicators, how well we are doing. We have to collect the data. And in those learning labs, we're going to be focusing on the next three: the clean, transform, explore the data. That's the data wrangling, we call. The analysis, that are going to be included the modeling and all the machine learning, everything that can do, and how to present your findings in reports and data visualization. So for clean, transform, and export the data, you're going to be mostly using in R a package named Tidyverse that it's a combination of many other packages that they try to select the best packages for data wrangling, like dplyr. It's very nice for transforming the data. Table is for tables. readr is to read your files. And ggplot, it's a very powerful visualization one. I believe that's one of the best packages to create plots and good visualizations. For the analysis, we're going to be using mostly, in the beginning at least, tidy models. That's again another big package that it's a combination of different packages, like the R sample. We're going to be sampling the data. Recipes is to create workflows. Parsnip is the machine learning package, and so on. You're going to have that. In some examples that are going to be in the future, we are going to also be including Python inside R. So we're going to use a package named Reticulate, where we can load Python from inside the R and use all the machine learning packages and all the advantage that you have in Python. So we can combine in both language. So that's amazing, something that you can do. And for the present findings and reports, you're gonna, and data visualization, basically you're gonna be talking more about Plotly and Shiny dashboards. Plotly is to create interactive plots, and Shiny is to create your app. So just an example, what is an app? I'm gonna show here. This is that's what I'm gonna present more deeply in the next lab. But this is a Shine that can create a Shine application that can create in R. So for this one, we are just trying to predict the price of the oil using the Facebook profit model. You can see what is a Facebook profit if you click on the link here. So it's a package for forecasting that can use in R and Python. You want to predict the WTI crude oil price, and the data was downloaded from the EIA, the US Energy Information Administration. If you click here, you can find where we downloaded the data. And here we have all the plots that can do. This is a digraph plot. It's not a Plotly, but we're going to talk about that on the next lab. And it's interactive. You can change the zoom, you can move around, and you can see what its value is on the top of the screen. We can see the components that were used to do these predictions from the Prophet. So we can create tabs, and we can create all those other visualizations from the metrics, and just look around how things are. And you can even change the horizon of the forecasting. For now, it's for 185 days. If you want to do for 1 year, we just select here how much days we want. We apply, so it's gonna take a few seconds to update because it's running now the models on the background. So as soon as it's updated, it's gonna appear here, the new plots and the new predictions. Those plots on the right are not gonna change because they are the model related. The model is trained already. We're not retraining the model in this app. So it's not gonna change the plots here, just this one. And now those are the new predictions for 1 year. So if you look here, that's how we are predicting the data. So the black dots are the true values that we have for the daily price of the crude oil. and the blue are the series that was created using the Facebook profile. Okay, so just now a small introduction. So that's what you want to be creating. And for that, you're going to be using the R, RStudio, and Shiny packages mostly. So R is a statistical programming language. So it's very used among the statisticians. It's called what is a functional programming. It's not a object-oriented programming. Means that you're not going to be creating classes for that. It's more calling functions for any object for any variable that you have created there. The code, it's the language, it's open source. The three of them, the R project, the RStudio, and Shiny, they're all open source. You can download for free and use for free. Basically, all packages that you use here, they are free. And if you want to use R, first you have to download the R language by itself. That's called the R project. If you click here, you can download from the website for your specific operational system. RStudio is the IDE to run Python, to run R. It's like the spider for Python. So this is how you're going to be using R inside this. This is the programming language, and this is the IDE to run the R. So you can also download from here, from their website. It's free. You have the paid versions if you want to use the RStudio server, but usually you're not gonna. That's not what you're gonna be doing here. And the Shiny is this app, the package that you can create those apps. So if you go to the Shiny website, it's very nice because they explain, they have a lot of examples in their gallery. So just a second, it's still loading. So if you go to the gallery, we can see a lot of examples of apps that were created by different companies, different users, and everything. So we have a lot for consulting, education, public healthcare, public sector, all type of different research, sports, and something that we don't see here that much, or I didn't find anyone. We have one for Pokemon. It's gonna find which Pokemon you're thinking about for you answering some questions. That's a nice one. I'm a Pokemon fan. And something that you never find here, that I couldn't find at least, are geoscience related projects can be for the oil and gas industry, can be for any other type of geoscience research. So that's something that you're going to be working with during this series. You're going to be creating apps that you cannot see here. So you're going to be doing something new. So here also we have some companies that use R a lot for their research, for their forecasting, and for their machine learning and for their applications. And to understand better R and RStudio and everything, we can go for some demonstration. So this is a RStudio, how you can do this is the IDE. So here in this side, you're gonna have the coding area where you have the macros that you can create it here. Here are the consoles where you can run something here, or the terminal, or the R markdown, or everything that you want to test. So if you just want to do 2 + 2 and run here, so you can just run fast tests in here. Here are going to be our environment area, where we're going to see all our variables that were created during this coding. And you can see if you have the DevTools developer version, you can also see the R and Python that you created. But you're not going to be going through this now. You can see the history of the commands that you used in the past. If you have any connections, I don't have any. Tutorial, you can see here. And here you can see the files that we are in this folder. You can see all the files that are created for this project. So usually we created a R project where everything that's going to be related to this R project is going to be saved here. all the functions and everything. So it's like an environment in Python, but it's going to be an environment for each project. We can create our files to run. In this case, I'm using R Markdown for the Python users. It's very similar to the IPython notebooks or for the Jupyter notebook. It's this example here on the left. When you create a R Markdown file, we have to include, it includes automatically. It's a YAML header that you can give some parameters of what you're doing and how you want to export your notebook. And we have the markdowns in here. Everything that's not inside any chunk is going to be a markdown. And you can define the H1 headers, H2 headers, and you can create a very beautiful file. You can include hyperlinks, equations using the MathJack library. It's come automatically, so it's like writing an equation in LaTeX, and you just put between dollar signs, and you can visualize it here. And when you want to create a cell that in our markdown called chunks, that's a coding chunk, it's like that. We created these 3 symbols and R. So, for example, to create a new one, that is, you press Ctrl Alt I, is going to create a new R chunk. So everything that's going to be inside here is going to be a code in R. And that's the area that you're going to be coding. For example, in this first one that I named the chunk packages, I'm even put some parameters for this chunk, like warning false means that any warning messages are not going to be appearing here, any warning messages, any messages at all, like any verbosity going to be shown. And if you're going to run this chunk here, so that's where we're loading our libraries for this research. In this area, it's where we are going to be loading our data. So it's very nice. It's a difference that you can use. You can use this arrow to say that's similar to equal. You can use both equal or the arrow to say that this variable is going to be equal everything that's outputting from here. And if you run this chunk, so you run as a R markdown, you can select in your project, in your global options, for example, in the R markdown, you can select if the plots are going to be posted inline or in windows. Show the output in a pop-up, never, or inline. Usually I put inline to be more similar to a Python notebook. So when you run, you can see all the output below here. And this is an interactive plot in Plotly, so it's going to be interactive here in this window as well. Another thing that I liked a lot is the dplyr package that use those symbols that are called pipe. It's very similar to the piping in Linux for who uses the command line. In Linux, where you run a command like grep and pipe and another command. So the output of this thing here, of this command here, is going to run this one. So this function here is going to be running the output of this one in the output of this, and this one in the output of this. So if you want to run just this selection, just to an example, so here we are loading our crude oil prices. If you select and press Ctrl Enter, we run just the selection. So that's what we're being loading here. We are loading a data frame, basically, from the CSV file that contains the day and the price of the oil. But a few things that when you are working with time series, you want to use these as time. And here it was loaded as character. So it's not going to work for our forecasting models. So what you're doing here, you're getting the output of this and then running this command named mutate for the dplyr, where you're going to be creating a new column where it's going to be in date format. It's going to be in year, month, day of the year, month. So if you want to run this selection, that's going to be the output, we created a new column that now is in date format. So now I want to remove this one and change the order of the columns. I want to put date before price. So I'm going to run this select. See, that's a concatenate. It's how you create a vector. And I created, it's going to be just date and the price of the WTI. So meaning that I'm not selecting this column. When I run this, so I have this output, just the date and the price WTI. And this last one is just to confirm that it's going to be a table. That's a kind of a data frame. That's the most used data frame in R, and the most new type of tables. And that's what we created. And also, if you want to do a plot, when I created this variable here, the WTI prices, running this, now I can call the WTI prices. If I just run this, it's going to show the table. But then what I'm going to do here is I'm running this, and in a pipe, the output of this, I'm going to apply this function that's plot times series. So I'm plotting. And then I don't need to select what's the data here, the data, because it knows that's coming from this. I just select which columns I want to plot. So I'm plotting date, the price, and some other parameters that I want to include in here. So when you run this, we created the plot. A big advantage to use the R Markdown as well is in how you can export your notebook. We have this knit here, that's a package named knit, that you're gonna knit this code or this file in some specific output. And you can select, for example, if you wanna do in HTML, in PDF, and to Word. In this specific file, we are doing to our HTML document. So what it's gonna do is gonna create this HTML. If I just click knit here, I'm not gonna do because it's gonna take a few seconds, a couple minutes actually. It's gonna create this HTML file that you can open in your web browser like that. So that's a way to do reports and all. So you're gonna have all those markdown language type here. You can create hyperlinks. You're gonna have a table of contents that you can navigate through your code easier. You can select if your code is not gonna be appearing, if it's gonna be appearing or not. And all of the interactive plots, they're gonna be interactive here. The difference from the Shiny application in here is that you don't have buttons to change and to do instant updates of your code. So that's why we do the Shiny applications, because you wanna do instant changes of what you're seeing. And that's how we create an app. So this is the app that you're creating for this price. We have to specify that you're using Shiny as a runtime. And in our series, mostly you're going to be using this Flex dashboard. That it's a simpler way, it's an easier way to use Shiny. So it's going to create a dashboard. If you don't specify that you're doing Shiny and you don't want to use any of the buttons here, you can create a dashboard that's going to be HTML, but it's going to be, again, very similar to this HTML here. We are going to not be changing anything like interactively, just the figures that are interactive. In this one, we are actually creating the application that we saw in the web browser. So that's an example how to run. It's going to be an R Markdown as well. So just going through very fast, but you're not going to go deep. Just in the next one, the next lab, we're going to explain a little better. So in Shiny, we can use like HTML tags to include our texting and other classes and everything that you want to do. And I'm going to talk in better in the next lab. We can include the slide input. This slider input is basically this button here. So that's coming from Shiny. and so on. So that's how we create it. And we can create as well our input parameters. And I'm just saying that this is a sidebar. So everything that's coming here, below here, is going to be included in this sidebar. And if you want to go to the other areas, so here I create a new column. That's where we can have tabs. And this column is related to this part here. I can select what the width is going to be, and so on. Another thing that I really like in our Markdown, because you can see here, we can tag off or tag on our document outline, and you can run very fast through your coding. So if you want to come to column and everything that's similar to a H2, a column, when you create a column, and it's going to be a subsection of the title, and when you have a matrix, it's going to be a H3. So you're going to see as a subsection, and the chunks as well. So those chunks are the coding chunks. You can even include names in here. For example, this one is going to be the sidebar. I do like that. So now it's changed here. I know this chunk is named sidebar. So if I want to come very fast to this coding chunk, I just click here. And if I want to include some options, some parameters, I just do comma. And you have all those options that you can include here. It's going to appear mostly automatically for you. So we can do like message, message, and false. So means that it's not going to show any message from this chunk. And another thing that we are going to be going through eventually on those labs, we're going to talk about styles as well, CSS styles, and how to create your style to be similar to your corporation. In this one, we created these templates where we have a cruise template for our applications. We can change these templates by changing this style CSS file. So we have the CSS file that you are defining in here, calling in here. And this is a CSS language where we can change all those parameters related to every part of our app. For example, in this one, we are changing the navigation bar and we are changing the colors. So I'm including this linear gradient color that go from a lighter blue to a darker blue. So that's why you see this gradient color in blue here in the nav bar, the navigation bar, and so on. And how are you going to be looking, which part you want to change in the CSS? We're going to talk also in other lab. It's about the Chrome DevTools. So it's very nice if you are using Google Chrome. And then you can just go and press F12. And then you're going to have, this is the DevTools from Chrome. So you can change here. I'm just going to put in a nice size to be below here. So that's what we have. We have the HTML file that was used to create this web page, this application. And we can check each of those contents. For example, this content, not here, I apologize that. So we can change all those parts. Here we have the CSS code that was used to create it here. And let's say that we want to change the navbar. We click here, the select an element, so we can go through and see all the elements that we have here. So let's select the navbar. So when you click here, we see that the navbar is defined here. So we have this class, navbar, navbar inverse, see? And you can see down here all the CSS codes that were used to create in here. So if you want to change, you can just copy, for example, the navbar here, copy this, and paste in here, and do our changes. So it's gonna overwrite the template that it has here. And if you just wanna see like happening now, for example, the color, you can click in the color here and select a different color and see what's happened. So you can see live in your browser what's happening. You're not changing the app, It's just for you, for your local machine that you're seeing this. As soon as we update, everything's gonna go back to what it was before. If you do a F5 to update the website. So, and that's how you're gonna use our skills, our knowledge of the RA skills to include some programming and to create some apps. So, and how to be a more complete data scientist. And I think for the presentation, that's it. So I'm gonna stop sharing, and now we're gonna start for the Q&A. So if you have any questions, just type there, and me and Daniel are gonna be answering you. Daniel, can.
Sure. Yeah, I just wanted to make a comment. If you are working with Python, for example, with Jupyter Lab or Jupyter Notebook, usually you can do all this markdown, not as much, but you can do some of these things. But what you cannot do is to see the variables, and that's kind of quite important when you are trying to understand the code. One thing is interesting about this R, although I don't have any experience with it, but I just by looking at Marcelo's presentation, is that you have a combination both of the debugging capability that allows you to see all the variables, plus all the flexibility of the markdown. Right? In Python, for example, if you want to see all the variables and do some debugging, you would normally have to switch to a Spider. Right? But then in the Spider, you cannot do all the markdown on all the text. You have to basically just put comments. So yeah, it seems it's a nice combination of the two.
Yeah, but for the Python, you can do that on VS Code. In VS Code, you can do the markdown and also the visualize the variables environment. And just to show here, I forgot to show. I'm going to just share my screen again very fast. For example, in the R, in here, you're talking about we created all those data frames. So we have this WTI price data frame. If I click here, we actually gonna open a new part here where you can see the data frame better. And you can filter, we can reorder and do some nice checks just for another type of analysis.
Do you have, Marcelo, an example in your code where you are using Python?
Not now, but we're going to be showing in the future. So you're going to be using the package Reticulate, and in some examples, you're going to be using the scikit-learn and TensorFlow. But for now, I don't have an example to show.
So there's a question, Marcelo, in the chat from Bob Canning. So you want to answer that?
What they call chunks. Yeah, that's correct, Rob. So the tables and the charts, they come from the R markdown that was right above the R chunk. Yeah. So everything that you run in the chunk is going to be plotted right below it. The tables, the interactive plots, or regular plots, or anything that you want to show below.
Now, this, Marcelo, this type of coding seems to be more oriented towards interactive and support presentations and things like that. If your problem involves something more like calculation, something typically you will do with, let's say, deep neural networks or things like that, you would do. You will just do it this way and include TensorFlow inside. Is right.
Yeah.
Is there a way you can pack all this, like you see in Python, for example, you have a notebook and you can convert it to Python and then run it in command line. Is there a way that you can do something like that with R and then output and then export the HTML or the PDF?
I never did that, but I believe so.
Sorry.
I believe you can do that, but I'm not sure. Python, yes, those are transferable. Actually, when you use the reticulate, maybe I can show a very fast example. I can do very fast now. For example, I want to create a new R Markdown. I go here in new, and I'm going to create a R Markdown. So I can set what type of output that I want to do. I'm just going to do a simple document for HTML. So when I do OK, it's going to create automatically this R Markdown. So it's going to be loading this data set named cars that it's from the R. So you can see, so if you run this document, everything, you can run one by one. I'm just gonna say that the echo of all the chunks are true, so the codes are gonna be appearing when you run the init. And let me just call this test. And then when you knit this to HTML by clicking here, it's going to create a HTML file that is going to be appearing on this side. And it's going to be like that. That's the HTML. And if you want to use Python, we have to include a new R chunk. So we call library, reticulate, and that's the library to use Python inside R. And you can even use which environment, if you have a virtual environment or Conda environment that you want to use here, you use like a use underscore. In my case, I have the Conda installed, the Anaconda. So I want to use some Conda environment that I created here. So I'm going to use the TensorFlow. I have one named the TensorFlow, where I run TensorFlow on my experiment, and the required, I'm gonna say true. So now I'm gonna be using the Python on these environments. So now if you wanna run Python in here, I created a Python chunk. So I put a shortcut in my R that's gonna be Ctrl-Alt-P. So I created the Python chunk. Now I have these cars in here. So let me just save as a df. If you press R Alt dash, so it's gonna be in here. So I have this df now, this data frame that has the speed and the distance. If I wanna convert, if I wanna convert to Python, I'm just gonna say now the data frame in Python is going to be equal R, saying that I'm picking it from the R, dot, and the name of the data frame there. So when I run this, now in Python, I have the data frame that was converted to Python. So if I just want to print it here and run this chunk, so it should print the data frame here, now that's in Python. So if I want to convert a data frame that was created in R to Python, I just use R, saying that I'm picking from the R, dot, and the name of the object. That can be data frame, can be mod, can be arrays or anything. And now I'm just call these with a different name, df_py, just to make it different, and run here. If I want to convert back to R, I'm going to create a R chunk, Ctrl-Alt-I, and then I'm going to say the df_py that I'm calling from there is going to be from pi, $, and the name of the variable that I have there. That's the df_py. So, and now if I do the df_py in R, so now it's back to R. So that's how we're going to be transferring information between R and Python. It's really simple. And here you can see the both. You can see the R variables that you created or the Python variables that you created. The difference, I believe, that if you click, yeah, as you can see here as well. So it's an object. Okay. So I'm going to stop sharing again. And do we have any more questions? Well, if you don't have any more questions, I believe that we can stop from here. So the next lab is going to be in 15 days from now. So we're going to be talking more deeply about these codes that I showed very fast about the forecasting using the Facebook Prophet. And they're going to be going through the code and how to do all the things, all the process, how to do all the data wrangling and everything, and how to create your app by the end. And in the end of the first lab, the lab one, the next lab, we are also going to be providing the codes in the next day after the lab, after the presentation. And I think this is it. I think, so see you guys in 2 weeks then.